All right, here's some more fun elevator problems, and let's take a look at number one. And we can talk about this, do it together, and I think you'll be able to do the rest of these if you understand number one. So the first thing, this is a 10-kilogram box. Here we go. We have the box. Is accelerating upward in an elevator with an acceleration of 2 meters per second squared. So the key thing here is it's accelerating upward. Since it's accelerating upward, on our free body diagram, we know that the upward force, whatever that force is, must be bigger than the downward force. How do I know that? Because it's accelerating upward. If it's accelerating upward, there has to be a net force upward. This force has to be bigger than this force. Well, what are these forces acting on the box, and are there any more? Well, let's first answer that question, what the forces are. The elevator floor is pushing up on the box. That could only be our upward force, and we're going to call that the force normal. Right? The downward force is the force that's on all objects that are on Earth, and that's the force of Earth's gravity, Fg. Okay? Now, we can put numbers to these in a second, but we know that this has to be bigger than this because the box is accelerating upward. Now, since it's accelerating upward at 2 meters per second squared, I can use this information and Newton's second law. If I think of Newton's second law, right, is F equals m times a. I know the mass of the box is 10 kilograms, and I also know that it has an acceleration of 2 meters per second squared. And what I find, and let's make this net force so there's no confusing, what I find is the net force on this box comes out to 20 newtons. Okay? Well, keeping in mind what we said originally, that this force is bigger than this force, we now know how much bigger this force is than this force of gravity. It must be 20 newtons bigger. This force must be 20 newtons bigger than this force. Well, the last thing we need to do to find well, actually, this question, it says find the net force. So we've actually already done that. So I'm going to zoom in here. This is 20 newtons, so we found that. And the other thing I was going to say is let's find out what the normal force actually is. What is this Fn force on the elevator? Well, on the box. Sorry, it's on the box. Well, since I know the net force is 20, I can find the force of gravity. They tell me it's a 10-kilogram box. So if I apply my equation for weight, right, we know that the weight of an object equals its mass times gravity, or g. So this is 10 times 9.8. Right, and I'm getting lazy not putting my units on. This would be kilograms, and this would be meters per second squared. This comes out to the weight is 98 newtons. Right? So this 98 newtons is the force of gravity. So then this force is 20 bigger, so it must be 118 newtons. So the normal force pushing up on the box is 118 newtons. And that's how you do a Newton's second law elevator problem. Let me know if you have questions.